In this example, we have a locomotive that travels from its initial position, D1, at 20 meters with respect to the 0 on our x-axis, which we've defined this way, to the right being positive x. So 20 meters is position D1, and it travels to position 2, D2, at 25 meters. Meanwhile, the caboose over here, it's on a parallel track and it's towed from its position D1 at 35 meters on our x-axis to its position D2 at 30 meters. And we want to know which piece of railroad equipment has a positive displacement and which has a negative displacement. Well, to analyze this situation, we first need available an equation that helps us calculate the change in displacement or the change in position, its displacement. We're using D to indicate position, and we know that it's a vector value, so the change in position or the displacement we'll say is position 2 minus position 1. However, if we're using the Walker textbook uses x as the variable that symbolizes position, or delta x standing for displacement. So displacement in the Walker text sort of convention would be delta x is equal to x final minus x initial, or final position minus initial position. Either way, we do the last position minus the first position. So let's consider the locomotive now. In the case of the locomotive, D2 minus D1 is 25 meters minus 20 meters. So the change in position, the displacement, is 5 meters from here to here, and by our definition of our axis, it's 5 meters in the forward direction. That means positive 5 meters. And then in the case of the caboose, D2 minus D1, position 2 minus position 1, is 30 meters minus 35 meters, so it starts here and goes like this. That is 30 minus 35 is negative 5 meters, and in this case the negative means that it has moved backwards with respect to the origin of our axis. So to answer the question then, the locomotive had the positive displacement because it moved 5 meters in the forward direction, and the caboose had the negative displacement because it moved 5 meters backwards or in the negative direction.